Okay, today's topic is basic recursive programs. Basic recursive programs. Okay. We will write a couple of recursive programs, very basic, and I will just want to give some introduction to basic recursive programs. So first we will write a sum of first n natural numbers. That's the first thing. Second thing, factorial of n. Okay, so sum of our first natural numbers means I'll write down some example. Sum of 1. Sum of 1 is, we know that first sum of first n, here n is 1, natural number is 1. Let's write equal to 1 also. Sum of 2 is 2 plus 1 is equal to 3. Sum of 3 equal to 3 plus 2 plus 1 equal to 6. Okay. Sum of 4 equal to 4 plus 3 plus 2 plus 1 10. Sum of 5 equal to 5 plus 4 plus 3 plus 2 plus 1 equal to 15. Okay, this is how we calculate the first n natural numbers, right? I will copy this one to factorial. So here what we want to is that we want to remove sum, replace the sum with empty, replace, and the closing bracket with the factorial symbol, replace. Next we want to change a plus symbol with replace a plus symbol with a multiplication symbol. We have done everything, right? Now we need to change this result. It's a 2, this is a 6 only, this is a 24, this is a 120. Okay, so what we want to is that this is the sum of first natural numbers, a factorial of n. Here if you write a recursive program, you need 3 things. First is subproblems. You need to find out the subproblems of the original problem. You should be able to find out a subproblem. Okay, subproblem. Second is combine result of subproblem. If you find one or more subproblem from the original problem, you will get the results of the subproblem, and you should be able to combine that so that you can return the original problem. You should be able to do the combining of the result. Third is base condition, atomic problem. There should be atomic problem. It means a base atomic problem, or it's usually we'll call a base problem, base case, or whatever you can call. So you should have a subproblem. If you get a problem, you should be able to find it's a subproblem, one or more subproblems, combined results of subproblems. So if you get a sub problem, you should be able to get that result and do combining with something, and you should return. These three things is needed for writing a recursion problem. So we need to find out these three things here. Okay, so by seeing this one, can we make any sub problem? So let us start from here. So here, if you're looking, you can see that one, sum of first 4 is same like here, right? So what you can do is that one, copy this one. It's a sub problem, right? Copy and paste here. Now you saw that one, the sum of 5, you can write 5 plus sum of 4. If you're looking here, same way, this is the sum of 3. You can write a sum of 3. This is a sum of 2. You can write a sum 2. This is actually sum of 1. Let us, for the sake of consistency, let us write here this also. But here there is no sub problem, right? It is atomic problem. It means this is a base problem. If you sum of 1 is 1, but sum of 2 plus sum of 1, sum of 3 is 3 plus sum of 3. This is we are writing as a problem of sub problem. Okay, we are getting a sub problem to solve that problem. That's all. Okay, the similar way, if you are looking that one here, this is a factorial of 4. Factorial of 4. This is a factorial of 3. This is a factorial of 2. This is a factorial of 1. For consistency, we'll write factorial 1, right? There is no sub problem here, so it's a base problem. So we got these things. So we got the base problem, we got the sub problem, and here we got how to combine this one. Using the addition, we will combine sub problem results with here is that number itself. That's how we are combining. We are using addition. Here we are using the multiplication. Okay, so okay, now we need to write let me write some like a mathematical notation. Sum of 1 equal to 1 if n equal to 1, right? Sorry, here is a sum of n equal to 1 if n is equal to 1. You can see this is a base problem, so we can write if sum of n equal to 1 if n is equal to 1. Otherwise, sum of n equal to you can see here, right? This is a n, this is n minus 1. You can see that pattern everywhere. It's a n minus 1 like that. So you will write n plus sum of n minus 1. This is the sum of first n natural number. This is the problem. You can write some like a mathematical notation. Sum of n is equal to 1 if n is equal to 1. Sum of n equal to n plus sum of n minus 1. The similar way here you can write n factorial equal to 1 if n is equal to 1. This is otherwise. Okay, here if n equal to 1, okay, n equal to n into n minus 1 factorial, otherwise. Okay, so we got that one. We got a base problem. If the n is 1, result is 1. That's a base problem here. Here base problem is n is equal to 1, result is 1. And next is a sub problem. Sub problem is here sum of n minus 1 is a sub problem. Here also n1 minus is a sub problem. And here addition is the combining technique, combining the result. In factorial case is a multiplication. So now how to write this program in code. It's very simple. Define, first we will write a sum of n, number n. So first what you need to do is, then you need to check the base condition, n equal to 1, return 1. Okay, first we wrote a base condition. Next you need to write a sub problem. Here n plus sum of n minus 1. That's all. You wrote that base condition, and you wrote the sub problem, and it is combined with n. Some calculation here, plus is the combining technique. That's operator we are using here, and sub problem. That's it. Let me write an example. Sum of n, 5, right? We know that 5 is a 15. Yeah, we got 15. This is a sum of 5 is 15. Okay. Okay, right. Now let me write a factorial. Factorial is similar like sum of n only, not much difference. Let me do one thing. Let me copy the same thing. Okay, here it's a factorial. The problem is a factorial, and we know that one base condition same, like if the n is 1, result is 1. But the only difference here, it's a multiplication operator. That's all. Okay, now let me check an example. We'll write 5. 5 should be 120, right? Yeah, you got 120. That's all. Sub problem, combining technique, and base problem. How much time it took? There is any timing? I can't see anywhere timing. Somewhere down, 12 minutes. Okay, we have some more time. So yeah, factorial wrote, sum of n we wrote. It's very simple, not much there. Very basic problem, these two. Now let us go to another problem. What is the problem? Fibonacci problem. Fibonacci numbers there. Let us look that. Fibonacci number is it is starting from 0, then 1. That's the first two numbers is this one, 0 and 1. 0th element is 0 and the first element is 1. Hereafter each number is formed by combining previous two. Here the previous two is 0 and 1. So sum of 0 and 1 is 1. Next sum is previous 2 is these two. That means sum is 2. Then 2 and 1 is 3. Like that it will go. Okay. So here we can write in a mathematical notation. Fibonacci numbers. Okay. So first you can see here, right? Similar way, let us write in mathematical notation. Fibonacci is equal to 0 if n equal to 0. Okay, similar way, Fibonacci of n equal to 1 if n equal to 1. Fibonacci n equal to, now otherwise condition should previous 2, right? Previous 2 means n minus 2 is first, plus second is the n minus 1. previous to this, otherwise. Okay, this is the problem. These are the two base conditions. This is the rest of the condition. So here you can see that we are here two sub problems are there, right? One is based on n minus 2, another is based on n minus 1, and we use addition as a combining operator. Then here is the base conditions. Okay, we got these three things there, right? Okay, let me write this problem. Factorial n. So here if n equal to 0, return 0, we are writing base condition actually. 1 means return 1. So here we can you can combine both, like n is less than or equal to 1, return n, but for clarity I will write like this, separately I will write. Now we wrote both base condition. Now we need to write the sub problems. Sub problem is Fibonacci n minus 2 plus Fibonacci n minus 1, right? Oh, here factor I wrote fib. Okay, now let me write an example for testing. Fifth element. Actually the element is starting from 0. Fifth element is a 5. Then sixth element 8, seventh element 13. Okay, let us check. Fifth element 0, 1, 2, 3, 4, 5, 6, 7. Yeah, we got 7. Seventh element is 13. So the code is correct. Here what basically we have done, first wrote that two base conditions, base problem we solved here. Then we wrote that sub problems. This is a sub problem, and we combined with addition. Okay, so yeah, we wrote a factorial, sum of numbers, and a Fibonacci. Next we will write a palindromic, checking a palindromic. How we will write a palindromic? Let me put some space here. Palindromic, whether that condition result is true or false, whether the string is palindromic or not. Okay, so for example, assume we want to check madam is palindromic or not. So how can you check this one? So here basically what we are doing is that we are let me write a bigger Malayalam. Whether how to check this one? Basically what you need to check this: first element and the second element is correct or not, and the substring is this one, the middle and the rest of the rest of the string except the first and last character, whether that's a sub problem, whether that's a palindromic or not, and like that. Okay, I will write mathematical notation. Pal is it palindromic? Is pal string equal to, see here the base result here result is a true or false, right? So true if length of s less than or equal to 1. It means a string may be empty string is you can consider as a palindromic, and only one character, if there is only one character in the string, you can consider it as a palindromic. That's a base condition. Is pal is s is true if, okay. Otherwise we need base condition we wrote. Otherwise, so how you checking is that one equal to, it's actually Boolean expression, this one actually. string of, you need to take the first character, it should be equal to string of last character. It's a Python notation. 0 is the first element, minus 1 is the last element. It should be equal, and it's a combining operator. It's a boolean and logical and whatever it is. And then you need a sub problem here, is pal. So here we need string, substring, by removing the first and last character, right? So you can use the Python notation. Yeah, it's basically a string a string after removing the first and last character. So here you can see that we wrote a base condition. The string is palindromic if the length of the string is less than or equal to 1, and otherwise the first and last character should be same, and a substring after removing the first and last character is also palindromic. So it's a subproblem, and is a combining operator, and it's a base condition. Let me write that code here. I'll remove this Fibonacci. Def is pal string. Okay, now we need to write the base condition. Length of s is equal to 0, sorry, is equal to 1, return true. Otherwise you need to write the otherwise. I didn't write otherwise there. What is the otherwise? Otherwise. Okay, here what you need to do is that s of 0, first character equal to last character, and is pal, the middle sub character, substring should be palindromic. Then if first and second character is equal to, both are equal, and substring is palindromic, then the string is palindromic, like that is. Print is pal. Let's check madam is palindromic or not. Yes, true. Here it's a case sensitive code I wrote. It is okay. Now it's a true, right? Madam is true. I will add s there. It's false. Let me check Malayalam. True. D, I will add D here. False. Yeah. Okay. In this code we saw is a base condition, base problem, and this is a sub problem we created here, and yeah, it is combining operator, and the sub problem result combining with the check here in this level itself. Some check is happening, some calculation is happening, that result combining with the sub problem result with AND. Okay, I hope my explanation was useful for you, and let me summarize. If you want to write see all the problem here I discussed very basic recursive problems, and there are very efficient methods to solve all these problems, but here this is given as an example for basic recursive programs. Okay, for a recursive problem you will see these three things. First is there would be some subproblems. You need subproblem. If you get a problem, you should be able to get its subproblem. Second is you should be able to combine. Third is there should be a base problem. That's basically that's a terminating recursion. base case actually. So palindromic, we saw that one. This is the base case. If the any length of the string is 0 less than or equal to 0, then it's automatic. It is it's a palindromic. Otherwise, you need to check first and last character are the same, and middle of the string, substring should be palindromic. Then only it will be palindromic. Otherwise, it is not. So like that we saw Fibonacci number, then sum of Gaussian natural number, and factorial. Thank you.